So why am I telling you all these things about loops? Well, quite simply, we're going to use one to build this. This is the golden spiral. So this is a graphical representation of the Fibonacci sequence. Fibonacci sequence is a sequence of numbers that each one is the sum of the previous two. So that's 0 and 0, apart from the first one, which is 0 and 1. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 3 is 8. You get the idea. So we're going to use the math to do this, and we're going to construct this strand. It is laid out in the PowerPoint, but now you get to watch me do it as well. As I said, the Fibonacci sequence is a sequence of numbers. That gives us our first clue on how we're going to build it. We're going to have a sequence array. What a sequence array does is you give it the size of the array you want, you tell it what you want it to start on, and how big is each step in the array. So in our case, let's split this out into its own node for control. We'll just do 10. And if I just put 1 in here, that's going to give me 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The only way I'm actually going to get a Fibonacci sequence out of this is by putting it inside a loop. Now, that would be a very acceptable way to do this, but I'm not going to do it that way. What I'm going to do is just use this to create an array and then put it into a loop. And it needs to be an iterate loop. So here's our iterate loop. And we're going to do the same as we did before. We're going to make this into our max iterations. Now what this sequence array is doing right now, if I change that to 0, that is literally going to give me this number of this value in an array. It's going to give me 10 zeros. So there's another way to do that, just so you know. You can also do this with resize array. And you'll need to move that down to the size, and then the default needs to be 0. This will also give us an array of this many things that is 0. You could plug another array into this and resize it down to this size, and then it would just use the default when it didn't have something. But you can use either of these, they produce the same result. I'm just going to kill that one. We'll go with what's in the PowerPoint. So let's take this and plug it into our iterate. And we're going to start to build the sequence. So here is the Fibonacci sequence. The next number is found by adding up the two numbers before it, 1 and 1, etc., etc., etc. So we need to build something that does this. We can use our indices for that, and what we're going to do here is put in a little bit of logic and say, hey, are you less than 2? So if our current index is less than 2, really what the output we want is the current index, because 0 and 1, which are less than 2, are the first two numbers of the Fibonacci sequence. 0 and 1 are going to be the indices of the loop below 2. So that's pretty easy. Get that set up straight away. So we say, hey, if we're less than 2, which is 0 and 1, then really we just want to take that, convert it to a float, because we have a float sequence that we're making. So we convert that to a float, and we'll just pop that in there. And that's great. That's got our first two sorted out already. Now we've got to just do the mechanics of the loop and things. So what we need to do is work out what we're going to do if it's not less than 2. Well, if it's not less than 2, we need to get the sequence. We need to get the last value in the sequence and the one before that and add them together. So let's get that sorted out. But first, this is an iterate loop. We need to set up our port loops. And what we're going to do is we're actually just looping through the sequence, and we're going to be adding to the sequence. Because remember, we'll be setting in the sequence. You remember, this is just a sequence of zeros. There's nothing coming in. There's no data. The only data coming in is 10 zeros, or however many of this times 0. So that's pretty easy. Let's make sure first that this isn't an auto port. And you can tell it's an auto port because it has a little bar above the hat. So we'll right click on that, port type, float. And I'm just going to drag this all the way to the output and then break that connection. This again needs to be an array float. We'll call this Fibonacci out. And we don't need to connect anything just yet, but we'll set our port state. So now sequence in, Fibonacci out. That just means it's going to go around and use the output for the next one. So how are we going to get this above 2 thing? Well, like I said, we'll take our sequence and we'll do get from array. So if I was just to get this from array, this would get the current one. We want the one before that. So we take our current index, we subtract 1 from it. Let's just set that to 1. So we've subtracted 1 from it, and we're just going to get, that's the last in the sequence. Okay, that's the first one we got. And then we can do exactly the same. Copy and paste. And just get these lined up so they look a little easier. And this time we're taking not the last one, but the one before that. So we're subtracting 2 from the current index and getting from the array. So what we've got to do now is add those two together. So this will be the next in the array. That goes into our false case. So if it's less than 2, it's just going to take the index. If it's greater than 2, it's going to take this calculation, which is the last 2 in the sequence added together. All we have to do now is one set an array. So we're going to go set an array like that. This is the array we're going to set our data into. This is the index at which we're going to set it. And this is the data that we're putting into the array. After that, output goes out like that, and we should be done. So let's double check that. So I'm just going to make an output and a mesh cube. Mesh cube's got nothing to do with it, but it's going to activate my output for me. So we'll turn that in there. Got a cube, don't worry about that. We don't really need to worry about that at all. What we need to worry about is this. Put a watch point here. So we have 10 values. The beginning one is 0 and the end is 34. Let's check our Fibonacci sequence. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0, 1, 1, 2, 3, 5, 8, 13, 21, 34. So we know that our beginning and our end match that. And this is the first thing we're going to talk about today with debugging. What if I want to check that whole sequence? How do I get to see that whole sequence? Well, there's a couple of ways to do it. One way is to get it out into a dump object, but at that point I'm going to have to set it as a property on an object and dump it out to a text file. So we're going to use another way that I use all the time because it's just a really quick check. I'm going to use a get from array like that. And then I'm just going to put that out. So right now I'll need to, of course, change that to a float. And this is going to give me the first value in my array, index 0, which is 0. We can check it against our Fibonacci here. So there's the 0. Our next one should be 1. So let's change that to the, and it's 1. And the one after that should be 1 as well. 0, 1, 1. Cool. So let's have a look at 3. That's 2, 3, 5. Next one should be 8. Then 13. Then 21. Then 34. We've created the Fibonacci sequence. And this is a good way to debug your data if you don't want to go through the trouble of putting it out to a dump object or anything like that, or downloading any sort of compound packs that allow you to see things like that. If you just want to really quickly check it, do a get from array, throw a watch point on there, and you don't even need to do what I did. You can literally just walk through the array like that just to check what's going on. So yeah, that's the debug stuff. So we have a Fibonacci sequence. So let's just get this out. And again, I actually don't need that, so we'll delete that for now. We'll delete this as well. Now that we've made the sequence, we've got our Fibonacci sequence here, and find out what we have to do for the rest of this. So we come down to here. What we're actually doing, let's just zoom out there a little bit. What we're actually going to be doing is using an iterate loop to build the points to make our strand around. Now this is all in the PowerPoint, like you can see here, but let's get this built first so you can watch me build it. So there we go, another iterate loop. Not helping us tremendously much just yet, but we can start hooking things up. So I think the first thing that we need to hook up to it is our max iterations. So we're not building too many iterations, if you know what I'm saying. That's good, and we're going to need some things in here. The first thing we're going to need is this. The Fibonacci is going to be fairly important to this, so we'll plug that in. We're going to be using that. Because we're using an iterate loop, we're going to need a starting position and a starting direction for our points. So that's our starting position, and this is our starting direction. So let's get those made. I'm going to need a couple of values, and they're going to need to be vectors. So let's just make a vector. Like, oh, that was a vector 4. Let's make a vector 3. That's much more important. And the first one's going to be our starting position. We'll just leave that at 0, 0, 0. Because we wanted to output multiple points, this needs to be an array. So the easiest way to do that is just build array. So we're building an array and we'll feed that in and we will call that positions array. And then this one is going to need to be our direction. And our direction is minus, you need to imagine that we're looking downwards here from above. So our direction is that if this is the X direction and this is the Z direction, it's going to be, as you can see here, if you squint, oh, sorry, this is the X and this is the Z, it's going to be -1, 0, 0. So our direction to start with is -X, 0 and Y, 0 and Z. So let's pop that in there and we'll give that a name as well. We'll call that point direction. Cool. So we're now kind of ready to get in here and set things up. Let's jump in. So the first thing I'm going to do is make sure that these guys, not that one so much, but this one, are not auto ports. That's important. Like so, and then I'm going to hook these up to the output. And again, make sure they're not auto ports. Break those connections. So this is just getting ready for our iterations. Give this a rename. Call this out positions. We'll try and spell it right. And we'll call this point direction FP for feedback port. So we know what we're doing. And then let's just make our feedback ports. Port state, that's our positions array. And this one is our point direction. Cool. So what do we have to do? Well, the first thing we have to do inside here is another if statement for what happens when it's less than 2. What we'll do here is same as we did before. That to be less than 2. We're going to use this a couple of times, so we'll just leave that out there for now. We'll pop in an if statement as well. And we'll come back to that in a minute. So first thing we're going to need to do is get from the Fibonacci sequence, because we're going to use that number, so 1, 1, 2, 3, etc., to scale our direction vector, which will give us the point position for our final point once we've done our rotations and things. So we'll do that first. We'll just do a get from array as we do. So we're getting from our Fibonacci sequence now, and we don't want the most recent one. We want the last one for this. So again, we'll have to do a subtract, very much like the last one. Make ourselves a value, and we're just going to take 1 off here, like that. That gets into our get from array. From there, we're going to multiply our direction vector. So take our point direction, multiply that by this. And what this is going to do is, like, our first vector will be 0, so it won't do anything. Well, our first 2 won't affect it because they're coming out through here. The first time we do this, will be the direction vector multiplied by 2. Then 3, then 4, then 5. So not only are we going to change our rotation, we're going to change how long how far away from the origin that rotation is. So let's just name some things here. We'll call this scaled direction vector, so we know what we're dealing with. And that's probably the first thing that we need to do. Then what we'll need to do is set the center of our rotation. And the easiest way to do that is to take our scaled direction vector, subtract, and we're going to take the last position in the positions array. So this is the last position we had. Last in array. Oh, I got that around the wrong way. So we take that and then we subtract our direction vector from that. And that is going to give us, and that's going to give us our center of rotation. So let's name that so we know what we're doing. So now it's going to be time to do the rotations. And to do the rotations, we're going to need to do a little bit of fun stuff with our old friend pi. So here's pi. Because this is worked out in radians, we're going to be rotating by quaternions. We need to get what is a quarter turn in radians. What is 90 degrees in radians? 2 pi is the same, so 2 times pi is the same as 360 degrees in radians. So really, if we just divide that by 4, what we get is half pi. We've got a node to handle that. Half of, so we're taking pi, we're getting half of it. So now we have half of our good friend pi. Why is pi our good friend? Well, pi is our good friend because we like to do circles, and pi is really good for doing circles. Now this is basically the radian version of 90 degrees, and if you have a look at our PowerPoint, we'll just go back to here. We are turning our direction 90 degrees every time. So that's what we're going to need pi for, and we're actually working on the rotating the scaled vector at the moment. So we have half of pi, which replaces this divide, and we need an axis angle to quaternion out. And this will become our radians. So this is how much we're turning it by, and because we're looking top down, remember we've got this placeholder cube here right now. Because we're looking top down, our axis that we're rotating around will be the y-axis. So we're going to rotate around this way. That's cool. We've got our axis angle to quaternion down. Of course, that just gives us the quaternion to rotate by, so now we have to rotate by quaternion. So you see that goes in there, that's our rotation, and then we'll be rotating our scale direction vector. So our vector gets rotated, and then we're going to use that to make our new position. So here's our last in array, and here's our center of rotation. So now what we need to do is we need to add this position to that, and this will give us our new position. So that then goes into our if statement. Remember, we're doing 2 different things. One's less than 2, one's greater than 2. And we want this to happen, this one to happen when it's not less than 2, so when it's greater than 2, and that becomes our out positions. Well, the reason that didn't work is this is looking for a position array, and we're just giving it the latest position. That was my fault. What we need to do is take the array coming in, the positions array, which is this guy here, and we're going to build array, because what we're doing is outputting the next step in the array. So this is what becomes the next in the array. So that goes in there. And then the array is what we're putting out to our out positions. We still need something in the true case though. What do we need in the true case? Basically, we just need to put the input positions array in, because the first 2 are 0 and 1, which is what we've got. So that goes in there, and that's our positions. And then we have to, inside of our loop, we have to update our rotation so that next time it rotates 90 degrees, it doesn't rotate from 0, which is what it started with, -1, 0, 0. It rotates from whatever it's put out for the last one. So that one, we just normalize that. So it basically makes it a unit vector. And then this one pops out to here. So if I've done everything right, let's just create some points and get a point scope so we can see things like that. Out positions into point position, points into point geo, and then just a couple of little quick adjustments here. Let's make them red so they're easy to see. Let's make them a bit bigger so we can actually see them. Disk is fine. Let's just pop this into here and see what we get. Okay, we've got nothing at all, which, to be honest with you, is what I intended. Half of what we're going to talk about today, as well as strands. Strands are a big thing today. But as well as strands, what we're going to talk about today is troubleshooting. So we'll start with a compound you've made yourself, and then we'll move on to a compound that someone else gives you. Both of these, you need to be able to trace down where the error is and fix it if you've made a mistake yourself. Even if the compound someone has given you, say it's your lead or it's another TA, another TD, one of the programmers, whatever. Even if it's working perfectly, you need to be able to trace the data through that compound and see how it's working, even if it's just an overview. So the first thing we're going to tackle is there's a mistake here somewhere. I'm not getting something. I'm not getting anything out, and it's not giving me any indication of why. So the first thing I'll do is try and change this to another type of shape, just in case my point scope's not working. Doesn't seem to help. I'm trying to try and make that a lot bigger. Now look, I'm getting something. I'm getting something there. But it's not the spiral that I'm trying to achieve. So what this tells me is I have data coming out of here, and it's only 1. And it should be 10, because I'm putting 10 iterations in here. So that gives me a clue. Actually, no, it doesn't, because point scope makes an array of 1. So we found something out, but it's not what we need. So let's check the next bit of data, which is the point positions coming out. Let's see what we've got here. Okay, so here's an error. I've got the right number of positions out, but they're all 0. So what that tells me is that somewhere in here, there's a mistake. There's not a mistake with the loop. The loop is doing what it's supposed to be doing, but I'm not getting any data out. Well, I'm getting data out, but all of those data are zeros. So let's start. So basically what we're going to be doing is tracing back along the positions, because that's what's giving us a problem. Tracing back along the positions to find out what's gone wrong. So we've got zeros there. So the first thing we'll check is this. This only happens twice, and that's 0, 0, 0. So we can come back to that because that one's a little tricky. Still getting zeros here. So are we getting zeros here? Yes, we are. By the way, I'm pressing W. I'm selecting my noodle and pressing W to get the watch point. You can also right click on the noodle and go add watch point. We'll give you the same thing. All right, so at this point, where this add is, we've got 2 streams coming together. And we don't have any data on any of them. So let's go through and find out what's going on. So what's coming in first? The direction vector. Direction vector 0, -1, 0. So that's changed. It's obviously gone through the loop and changed the direction vector a couple of times. Not entirely sure what's going on there, but we'll find it. Because this is all a part of being a technical artist, is that you've built something, it's not working immediately. So that tells me my sequence is working fine. Sequence of 10, minimum 0, maximum 34. This was the Fibonacci sequence that we built. We'll check our get from array. Yep, last value is 21, which is the one before. 1 minus, that's fine, that's perfect. So those guys are working. What you can do, if you like to keep things organized, is once you've checked something and you know that it's working, you can put a backdrop around it, like that. Only if you want to. I don't tend to. Well, I do with a bigger compound. This is quite a small one. So next thing is, this is a multiply of our direction vector. A direction vector is coming in. But what's coming out of here is zeros, basically. So this might just be a clue, because we've definitely got something coming in here, but what's coming out are all zeros. That tells me that perhaps the point direction vector is just multiplying by 0 all the time, which is odd, because this is -1, 0, 0. But that's a clue. And put that in the back of your mind and just take a look at that, because everything is just zeroing out somewhere, which, you know, tells me that it might just be something like a multiplication that's not doing right. So I'm kind of narrowing this into the rotation vectors. That's all working. So it's our vector. Somewhere in our vector not working right. So what I'm looking at here is the outgoing rotation vector, and it's going to zeros. And the reason for that is we need this compound to do 2 things. One, if its current index is less than 2, and 1 if its current index is greater than 2. We need to do it here as well. And so the way I trace that back, I mean, I had a little advantage in that I knew what I was doing to start with, but the way I traced that back was quite simply, what was coming out of here was always 0. Always 0, always 0, always 0. And so if you're adding 0 to the position, I've got 9 positions and they're all in the same place. So I got 9 points there. and they're all in the same place. And the reason for that is I deliberately left out the if statement from the new rotation vector, or the new direction vector. So let's pop that in now. So we'll just make another. Because I want to use the same condition, all I really need to do is like copy and paste this if statement and just break the true and false here. So that's just saved me some time. So this is what's going to happen after it's 2. And at that point, what we're going to do then is essentially the first 2 points can just go in the initial direction. So we'll just put the point direction in there, like that. And now we have our spiral. It doesn't quite look like it at the moment because those are very big for our troubleshooting purposes. But if we come back to our point scope and just take this down to 0.2, you can start to see, well, this maybe I don't think we need our companion cube anymore. You can start to see that the spiral is now working. So it's a really, really handy skill to have, is learning the tools you've got to troubleshoot what's going on. Now, I deliberately left that if statement out to induce an error in this that wouldn't show up. So it was still outputting the right data. It wasn't breaking anything. There wasn't an error. But what was happening is that the position was always becoming 0, or it's always becoming whatever the center of rotation is. So that center of rotation is always 0, 0, 0 for this spiral. It all rotates around that point. So what it was outputting was just all of the points at 0, 0, 0. So, and as I said, I managed to trace that down by looking at what the data was coming through here. And you can see now that we've got a last, min, and max, and they're not all zeros anymore. There's -1s and 1s in there. The y will always be 0 because that's the axis we're rotating around. But before, if I do this, and I'll pop that in there, you can see now it's come back to 0, 0, 0 because it's always taking it's rotating 0 around an axis, so it's coming out 0. Plug this back in, and of course we need to plug this back in as well. And we've got our spiral back, and we've got all our numbers. So that's just a really quick sort of how to quickly troubleshoot something. We'll be doing it as we go from now on. But now that doesn't matter. Now we're here. We've got our spiral. Now the spiral we've got here, if we jump back to our PowerPoint really, really quickly and come down a bit. Oops, not that far. What we've got is we've just got our main points. We actually need to put points in between those to build an actual spiral that looks a bit more like this. All right, so if I was to build this now, you'd get angles. If I was to, I could build strands out of it now. That's absolutely fine. But you would not get this curve, and the curve is what we're after. The spiral is what we're after. So let's go ahead and do that. Now it's on slide 12 of the PowerPoint if you want to just do it yourself. But all we're doing is we're adding more divisions into the rotation at this point. So you're essentially dividing the rotation into more steps. So it's not quite rotating as much. So I'll just leave this here. Remember, it's slide 12 of the PowerPoint presentation, and you can see how it's working here. We're dividing it by more steps, so we're getting more steps between the points. And let's go set that up. So here's our rotation area right now. And we're going to need some things coming in on a new line to get the numbers that we need. We're basically going to need to insert something in here. And it's going to come from the Fibonacci sequence. So let's start off with how many points do we want in between each point that we have now. So I'm just going to put down a value node. And I'm going to make that a float to start with. And 10's a good start, right? 10 and 10's what's in the PowerPoint, so it's less confusing. So then I'm going to take my Fibonacci number like this and multiply it. So this is now going to give me 10 times my Fibonacci number, whatever that is that we're getting from the array at this point. So it'll start off at 0, and then 1, and then 2, and then 3, and then 5, and then 8, and it'll multiply those by 10. So what we're going to do is actually have a different number of separations based on how big our sequence is, which is good, because if you just had 10 would work here and here, it'd probably work here. It'd start to fall over here. It's definitely going to fall over here. And then as you get bigger and bigger. So what this is doing is giving us more steps based on the Fibonacci sequence, which is awesome. It's what we want. So I'm going to do a little bit of a thing where I'm going to convert this to an integer, like that. I'm going to put down a sequence array, if I can spell it right. A sequence array. All right, so this is a new sequence array, and remember this is happening every time through the loop, so it's making this sequence array, and this is going to be the size. And then quite simply, all I have to do here is take half of pi, divide it by the number of steps I've worked out here. So remember, this is taking the 90 degrees, dividing it by however many steps it is, which is 10 times the sequence, which is 10 times the Fibonacci sequence number that we're up to at this point. And that goes into the start of the sequence array and the step of the sequence array. So that means it's going to start here and get this many steps to here. And the next time through the loop, it'll start here and get this many steps to here. And then so on and so on and so on. Which is awesome. At this point, we've done it. So we've divided each new point and each curve through that new point using pi into a number of steps based on the Fibonacci sequence. So if we just hook this up here, we're broken again, and let's find out why. Again, more troubleshooting. So this error here, where it says no promotion exists from a value of type array math float 3 to a value type math float 3. What that's telling me, and you can see there, it's compiling top level compound Bifrost graph shape 1 around the port, iterate port direction FP. There's something wrong with this port. And what is wrong with this port is, originally, this isn't an array. This is quite simply a vector. It's a float 3. It's just a vector depiction of the direction we want to go in. But when I plug this in, which is splitting it up into 10, or not 10, splitting it up into an increasing number of divisions, everything downstream ripples through, becomes an array. And you can see that this is an array here because it's wearing a hat. And it's also auto looping, just out of interest. So what we need to do here is we really only need to output the last in the array to become what our next starting direction is. So we've even got a node called last in array. And we have our spiral. So do you see what happened there? Instead of trying to put an array out where it didn't want to go, I worked out that every time through the loop, I just need the last one in this array to get me my spiral position. Cool, there's our spiral. And it's a strand. Well, at this point, it's not. At this point, it's a bunch of points. So let's jump out. Go construct points here. We've got our point scope here. I'm going to make this much, much smaller, so you can just see the dotted. And let's make it into a disk as well, just for niceness, but that's a nice Fibonacci spiral going on. So it's at this point, we check the PowerPoint, this is where we are. So we need to build a strand out of this now. So what I'm going to do is I'm going to reverse this array for reasons that will become apparent later. And I'm going to construct a strand out of it. This, and let's just put these out of the way for now. We'll leave them there so we can see what we're doing. If I plug this in now, I'm going to get this, and let's get rid of that. So when you don't want to leave an empty hanging output, there's a couple of ways you can do things. You can delete port, or what I like to do is just put down an if statement like this and plug it back in. Now I can show and hide that as I like. So this is acting like a switch. What it actually is a control, more or less. I mean, we haven't wrapped it up into any publishing or anything yet, but now I can turn my points on and off. So that's a good looking strand until you do something like that, because this strand is lit. So we'll do what we did at the beginning of the video. We're going to, and you can see it in the PowerPoint as well, so size profile, shape, and diagnostic material. So let's set our size profile first, and we'll leave these as defaults to start with. So just 0.25 with this profile. And then we'll set our strand shape, SSSH will do that. Set strand shape, like this, and let's just make sure that's ribbon. And then assign diagnostic material. And this is an auto port, so that means I can change my value type to float 3, and that lets me type it in 1, 1, yellow, and then let's just output this. And there's our strand with its size profile on, which I can of course change if I want to, so I can bring this down here. Lovely. Up, down, I can change things, it's all good. So there we are, we've got the Fibonacci spiral. Now, some of you might be wondering what this guy does. Well, we have a PowerPoint slide for that. Strand offset is used for creating multiple strands. It takes an array that defines the start and end of each strand. For example, if the strand offset array is 0, 20, 40, 80, it will create 3 strands that are constructed from points 0 to 19, 20 to 39, and 40 to 79. So what we've got here is basically just a little compound, or just a little bit of node work that creates the offset array. So 0, 20, 40, 60, etc., etc., etc. So let's drop this down. So reverse array, we need, I'm going to pull these out. So if you select the compound and press full stop or period if you're an American, that's going to select everything downstream from that node, everything connected. If I hit comma, it's going to select everything connected upstream. So this is really good for laying out your graphs. If you hit that, hit period or full stop, and then just move it, you're moving everything, and it keeps your organization. So I need the size of this array to start with, which is cool. There we go. And I'm going to need to divide that by the number of points per strand that we want to end up with. So in this case, I'm going to divide it by 20 because we want 20 points per strand. At that point, it's make a sequence array of that size and a step of 20. And now if I plug this into my strand offset, it breaks. Why does it break? Because it doesn't like the fact that these are longs. So a long integer is a 64-bit integer. What it's looking for here, if I just hover over that, it wants an unsigned int. So I'm going to need to either convert everything here to an unsigned int, which I can do with 2 unsigned int. And let me just show you. So I'm going to hit full stop again, move that along a bit more, pop that in there, and then pop that in there, and see if we go red. We don't. And you can see that we now have multiple strands inside this. Why are they looking like that? Well, because we have a size profile set up that says I want to be wider at my 0 point than I am at my 1 point, and 0 and 1 represent the point ratio here. So you've now got something like this. We could assign different colors to those. We could do all kinds of things to those. But basically, that's how you would now divide this up into different strands. And if you wanted to change it, you could 10, you get more. 40, you get less, because it's the number of points per strand that we're setting up here. This isn't the number of strands in this curve, it's the number of points per strand that you wish to create. Or if we don't want to do this at all, we can just unplug it, go back to our normal strand, which is what I'm going to do because I'm now going to give you the bonus. And remember when I talked about, let's just backdrop these so we know what they are. Create strand offset array, and I'm going to show you something else too, where I right click here and tell this compound to show me its name. So you can say I want to see the value, so that's 4040, but I want the name right now. So show name. I'm just going to say points per strand so that we know what this is. And that can just happily sit there and do nothing. Bifrost doesn't calculate it. Bifrost doesn't do anything with it because it's not being pulled. So it's not, the data is not being used anywhere. So Bifrost is like, I don't need to calculate that. This will just make it slow. What are we doing now? Well, what we're doing now is a little bit of a bonus on this to show you what else you can do with a strand. I'll give you this file. Don't you worry too much about it. Let's do a little bit of a tidy up first. So let's just move these guys down. I actually don't think we need these anymore. This is the point display if we wanted to see the points, but we've got a nice strand now. So let's just kill that and delete those. Don't need those anymore. So we've just got a nice little cleanup, and I'm going to paste this. All right, so don't worry about this because this is going to come in not looking like this. But what the problem is here, again with the troubleshooting, what the problem is here is that this actually needs an object, and this is a pass node. So this is our input to this little bit here. What this wants is the strands. So it wants the actual strands to work with. So let's just pop this up here somewhere. And I'm going to turn off all of these for now. And once I pass in the actual strands themselves to this object, everything will go the way it should be again. And you can see our curve and everything. So when I turn this on, I get a little ball here. And what this is representing the sphere. What this is doing is animating along your strand. So if I go back to my 0 and just press play, you can see the little ball is moving along the strand, and you have some settings. So start frame, well, let's take that to 1. Let's get our speed up to 1 to see what that does. It goes a bit faster, gets further along before you hit the end of the frame range. So if I go like 120, play again. There you go. So this is just a really quick animate along path, and it's here for you to look at and work out how it's working. I'm not going to take you through it. Use this as an exercise. Understand that somebody's given you a compound or a tool or something in Bifrost, like you know what that is, you know what that is, you know what that is, you know what that is. If you don't know what type of node it is, you can see it here, type, or you can just make sure you're in here, press T, and it's going to put the type of the node above. Let's find another one somewhere, like here. It's going to put the type of the node above the name of the node. Compound iterate, long, that's a long number, float 3, build array, float 3, etc., etc. So that is the T key on the keyboard. So jump in here. It's really, really simple, or it looks that way. I'll give you one clue to get you started. This is where the animation happens. Okay, so this is a solver. And it's a point solver, and it's a point solver based on port feedback, which we did with our iterate loop. So I will give you this file. It'll look a little different than this because I'm going to clean it up and everybody's happy. But jump inside the animate along path, investigate it, play with some of the settings, start frame speed, see how it's set up to work, and see if you can nut out what's going on. Okay. Let's play that one more time. See if you can work out why it's going in that direction, for example. See if you can find a way to reverse the direction. Things like that. Have a play with it and